Welcome to a new test and teardown video. This time it's a Philips oscilloscope PM3226P 0 to 15 megahertz. That's a little bit funny, isn't it? And it's a 2-channel oscilloscope. It's quite small and compact compared to normal oscilloscopes. I mean, this is my hand, so it's definitely a mini size oscilloscope. It's really difficult to show on a video. Maybe we should have a banana for scale or something, I don't know. But it is a small oscilloscope. I just got this from a local flea market. And the guy that sold me this one said he gave up and he tried to repair it, and it's definitely defective. So what can we do with this one? It's from about 1976. Yeah, the first release of this model was 1976. I released quite a lot of oscilloscopes, especially from Philips. I think this is going to be my number 12 Philips oscilloscope video, and it's going to be my number 76 oscilloscope video. Oh, that is wild. Here at the back we can see the voltage selector. It's hidden in here. If we look at 240, okay, good. This is the Philips service sticker, and it was repaired in 81, and here we can see the full model number and serial number and all that kind of stuff. Aha, this is interesting, 18VA. So this is good information when I want to power this up. But first I want to open and do a good deep going visual inspection. So that was easy. Only one screw here, and then you pull out the entire chassis to the back. But then there's one little extra problem. This is the power connector, and it needs to go through that hole, so this is not going to happen easily, isn't it? So I need to open the power connector and then stick it through here. How annoying is that? Otherwise you have to bugger around with the chassis, and I don't want that. I want full flexibility. I think, yeah, exactly, I was right. This is a classic Philips thing. On most of their scopes you just pull like this, and then you can take out all this, and that is of course something I need to repair. I'll just take this away and save it for later, just in case I'm lucky to get a good nice picture on this thing. Then I can of course repair all this. I just don't want it to get more damaged. So what I want to see here is there a visible dark stripe? And yes, if you look real careful, you can see a little bit of a dark stripe. And this is of course the center line. This is where it was used most. And for whatever reason, people always wanted to have the center line in the middle. Sometimes I want to have it down so I can see positive signals. But if you're only working with analog signals like audio or something like that, you always want to have it in the middle. So that reveals a little bit how they have been using this for most of its age, or something like that maybe. I also find this one to be, just see, rotating, so I need to look a little bit at that. And we see some really nice design features in here. It's nicely protected, so you don't touch anything just by accident. So all this main stuff is good hidden. You could of course stick down your finger here and get into trouble. You can of course also do it in here. So this is the focus potentiometer all the way down here, far away from everything. Also a very good design. And the on off and the brightness is hidden down there, where it belongs, close to power entry cable. And let's look like this at the different circuit boards. We see of course a little bit of ICs and transistors and all that. It's not super modern, of course, because it's from 1976, the main design. We could probably expect to find, yeah, look at that. The date code is 77 on this IC. So that is the first hint. Oh yeah, look at the white trimmer stick there, goes to a normal trimmer here at the back. It is deadly corroded. Oh no, this is completely, oh, devastating. How bad is that? And if this one is so bad, oh man, we could definitely see a lot of other things, but this is not in any possible way going to work. So what exactly is this one doing? This one goes to a 0, common mode 0. So yeah, this will maybe pull the channel way out of screen. And this could also explain another thing that I found. Let me show you. So here at the main board, or the bottom part of it, we got the 2 analog input channels, and gain, all that kind of stuff. That will be deflection amplifiers. That will be the horizontal and the vertical deflection directly going to the screen. I really don't like the way that they go so close to mains entry like that. There's just no space for any of that. Maybe somebody's been poking around with this way too much or something like that. But what I found was the measuring needles pinpoints here. Look at especially the blue one. So somebody's been poking around with deflection. So I bet we got a deflection error or something like that, maybe. There's been solder on everything here. All those transistors been replaced. I really prefer to get scopes that just blew up and then nobody's touching them, and then I will be the one to do the first initial checking and finding and repairing and do the measurements. When somebody's else been poking around for a long time, that means, oh, there will be so many hidden hints and so many sidetracks. Okay, I was just a little bit scared this aluminium could be thin and flimsy, but this is good and stable. I can easily hold this whole scope. Oh, look at that here again. This trimmer here is completely corroded. So that is also not going to work, because all this, I mean, so we had like water in this, or was it left outside in the rain? How can this happen? Why aren't all of them this? Really? Why? What is going on? So now I need to go and check out all the rust and corrosion damage, and but I really think this is a sexy oscilloscope, and I really like everything is on the front. All the inputs and everything is on the front. It's nice and compact on your table. I really want to see this one work. This is such a nice scope and a really big screen for such a nice little compact scope. I feel I need to do my own power-up investigation, so let's just try and give it a little bit. And there you have it. I put everything like that, maybe. Let's just slowly crank it up and see if there's any smoke. So that will be 80 volts and it's using 4 watts. So I feel lucky going up 150 and it's 10 watts. So we get a little bit of light here, that is good. And that's 175 volts, 13 watts. Yeah, so I feel we can go all the way to 200. Yeah, look at that. Oh, we got a beam. And that is nice. So, intensity works. Focus also work. And that seems to be good. We got a lot of noise going on here. Where's this? Ah, so that is where we are at. Okay, oh, look at that, see? Something. That is interesting, it goes dim. Why are you doing that? Oh, it's way to the left. So this is probably position here, right? Okay. Oh, look at that. Where is it going? It's not going straight in any way. That is some weird. It looks like this is channel 1. Grounding, AC, DC. There's just a million things wrong with the analog input. And it's not Oh, so now channel 2 is on, and we got channel 2. Well, we got a lot of noise. This is probably on power supply or some other stuff, but that is not bad. Look at that. Why are you doing? There's definitely some funky. I can't explain why it's doing that. Well, it's alive. Look at this one. So this is a 1 megahertz sine wave input, and when I move the signal up and down, it's behaving like this. So this, we got, for this to happen, we need to have a very unlinear sweep depending on where we are in the horizontal. Look at that. So sweep now takes longer. Up here it goes faster. Really? Look at that. That is a very interesting fault. This is not funny at all. I spent like 2 days trying to repair this stupid scope because I really think it was a sexy size, and I really would like to have this working. And look at that. What we got here. That will be all the deflection transistors here for the horizontal, and all of those are of course pretty much okay. And you know what? I took out the entire horizontal deflection. It's completely empty. I don't know if we can see that really. Well, that's all the desoldered components. And that will be 2 resistors to make the horizontal plates at plus 100, as it is explained in the schematic. So let's try and zoom in a little bit on the schematic. So, where's my little pointer here? So all those measurements here, those 2, they explain the normal plate voltage of 100, and I measure 189 and 13. So it's all the way to hammered out to one side. And of course we can see some problems with all of this, but it has nothing to do with this. Well, there is, of course, maybe one of the resistors here that's open or something like that, but all the transistors, they're actually okay. But you couldn't really measure any of those resistors in circuit. All the resistors I have been measuring, they all appear to be good. But there is another thing that is funny. Now that I've put on a fixed DC on the horizontal, let's play with the vertical. And let's try and power this up while we look at the screen. I will try and make this real nice and fine like this, okay? So power up the thingy, and then you'll see why we can start to cry about all this. And if we turn the light a little bit away here, and intensity, hello, where are you? See, here we go. So this is the intensity, and I have of course hammered the focus all the way. See, it goes like this, okay? All right, let's play a little bit. Oh, what is happening here? Can we see what's going on? I hit something, and look at what I hit. You can even see the, see? We can see I hit some metal right there. And up here I also hit the deflection plates, and also something to the side. So there's something to the right, and then deflection plates, and something else up here that's different. So this scope was hammered so much, some of the metal or the focusing or the deflection, something inside the CRT is broken loose in one of the ends, and is now doing a it's definitely never going to work. So there's been a complete waste of time trying to repair this, instead of just figuring out what was wrong all along with the CRT. So that is one dumb sidetrack of the year. I am so sad to show you all how dumb I can be, but I think it is worthwhile talking about. I even spent a whole hour licking everything totally clean here with little I mean, I went, removed all the knobs and doing nice, because I was so sure I was going to figure out the deflection, and I was nicing up the schematic, and finding alternative transistors I got on stock, and I found my little stock of spare transistors, and I was so ready to go and do the whole, darn it, it's never going to work, this scope, and so sad. Look what I also did. I also wasted a long time gluing all this in and fixing this, so it's going to be fixed and nice, and hey, and it's all for nothing. What a dumb bad day. Well, so I better turn this off and go to bed early, because that is one of the worst. So I took out this tube, and darn, it's beautiful. I really love this tube. Such a nice design. However, let's look at the deflection plates. That will be the first deflection plates. All right. And then we got the other deflection plates, and they're hidden. Yeah, maybe we can see them. Let's see if I can make this a little bit more visual. Here you see them, right? Just down. Here's where you look, okay? And they are mounted to those big white glass bars in there. But see, they go into one point in the middle and one point up there. And maybe you can see what happened. Can you see this piece of glass here is broken? And that means everything is now tilted to the side. So when the beam comes through this first deflection, it hits this edge of the deflection down there. You can even see it's not straight anymore. Oh, here you can see how bent it is. And that is why I was wasting 1,000,000 hours repairing an electrical problem, but it's all a mechanical problem. Ha ha. So this was dropped many years ago, and here we go.